Okay. In this video, we are going to see the interface, that is the graphical user interface, the GUI I mentioned in the previous video. When you launch your the CPU sim icon from your desktop, this is what happens, right? This is what happens. I'm going to launch again for you, and we'll see. Look, I'm launching this. This is the icon, and this is what I get. This is, you see, this is an untitled text file. Like I told you, it has a text editor also. You can close this for the time being. Now look at this. It has various sections. If you see this, this is the top toolbar, right? Look at this. I'm going to bring it down. This is the top toolbar. What do you see here? File, edit, modify, execute, and help. We are going to work on modify for the time being, just to create the registers, etc. But we'll go step by step. You see here data, that is what number system are you using? Let's have des means decimal, binary, hexadecimal, unsigned decimal, and ASCII. Let's go with the default option here, des. You look here, you see registers. So this is the pane, or this is the table, or this is the section which will list all the registers which you have created. Right now, this is a new machine, new CPU, which you are trying to simulate, which you are trying to create, which you are trying to copy. आप नकल कर रहे हो CPU की, जैसे नकल करते हैं ना, किसी की एक्टर्स की नकल करते हैं, है ना? वो एक्चुअल तो नहीं होते, लेकिन बोलने में लगता है. So that is the meaning of simulator, kind of, not exactly, but vaguely that is the meaning of simulator. हम उसकी नकल कर रहे हैं कि CPU कैसा दिखता है. यहाँ पर देखिए, यहाँ पर रैम्स है. देयर आर नो रैम्स करंटली, मतलब अभी हमने कोई मेमोरी नहीं बनाई, कुछ नहीं बनाई है. यहाँ पर कुछ नहीं है हमारे पास. तो अब हम सबसे पहले हम असाइनमेंट खोलते हैं अपनी. ठीक है, हम सबसे पहले असाइनमेंट खोलते हैं, एंड वी विल सी what is the first question in the lab, and then we'll work. See, this is how we are going to work. We are going to pick up the question for the lab, and we are going to work step by step. Okay. Okay, so you can see my screen, the document I had sent you on the official WhatsApp group. In the second half of it contains what we are supposed to do in the practicals. So look at this. Read this. What does it say? Practical. Use simulator CPU Sim 3.6.9 or higher version for the implementation of the following. So first of all, we are going to create a CPU. We are going to simulate a CPU. Create a machine based on the following architecture. What is the meaning of architecture? By now you should know, right? Like when you make a building, when the construction workers make a building, before that there is an architect. Architect makes a blueprint. वो पेपर पे बनाता है, जिसको बोलते हैं नक्शा. तो जो वो नक्शा या जो मैप या जो आर्किटेक्चरल डिजाइन होता है, वो एक्चुअली बिल्डिंग तो वैसे तो नहीं होती. बिल्डिंग तो 3 डायमेंशनल होती है, फिजिकल होती है. बट दैट मैप इज it's a perception of that how this building is going to look like. All right. So similarly, we are going to create a CPU architecture. What do we have to create? Let's start from here. We have to create registers, right? How many registers we have to create? 1, 2, 3, 4, 5, 6, 7. So we are going to go over the registers again. IR is the instruction register, which is going to be 16 bits wide. DR, data register, is again going to be 16 bits wide. AC is accumulator, again 16 bits wide. AR is the address register, again this is 12 bits wide. PC is the program, which is 12 bits wide. I is the direct indirect bit, which is 1 bit wide. E is the enable bit, which is of the size 1 bit. So these are the registers we have to create. Let me go back to the CPU simulator and show you how to create register. You will come to modify, and you see here hardware modules. Click on hardware modules, right? You see what are the hardware modules you can create? Register, register array, condition bit, and RAM. Right now, we are going to create register. All right. So first register, which we had, that was, what was the name? IR. You can give it any name, but we will continue with the standard names, right? IR, instruction register, which is by default 16, initial value 0. Read only means you can only read from it. You cannot write onto it. We don't want this, so I'm not check marking this. Okay. Next, I'm going to create DR, data register, which is again 16-bit, initial value 0. Now I'm going to create accumulator. Again 16-bit, no change. Now I'm going to create AR, address register. Just see how I'm creating. You click on new and create. Now here I'm going to change the size because we saw that our address register is 12 bits. Why is it 12 bits? We are going to understand, right? We'll see why it is 12 bits. Then we have to create a program counter, and notice that the size of program counter and address register, these two are always of the same size. IR, DR, and accumulator, they are always of the same size as in CPU. As we progress in our theory classes, you will understand this. Let's see if there's any other register we are missing. So IR, DR, AC, AR, 5 these registers, 1, 2, 3, 4, 5, and 1, 2 I bit, indirect bit, and enable. So let's go here. Another new register, which we call it I, which stands for direct, indirect bit, and the size is 1 bit. Again, this is not read only, you can read and write. New is enable. Okay, again 1 bit. So you created all the registers, click OK, and you see what happens now. Look here. Earlier, this section was blank. There was no register. Now this has all the registers which you have created. Is it clear? All right, let's see what else do we have to do. We are just creating an architecture. So first step, registers we have created. And look at this, we have to create memory, that is RAM. We have to create a RAM of how many words? 4096. And what should be the size of RAM? 16 bits. This means each word of RAM stores 16 bits and there are 4096 words. All right. And each, okay, we'll come to it later, the instruction format. Now we have to, there's no RAM here, if you see. So again, we go to modify, we come to hardware modules, and what do I have to create now? I have to create RAM. All right. And what name do I want to give it? You can call it anything. You can call it my RAM. Or you can just call it RAM. Anything you can call it. Now length. Length means how many words are there. And we saw in our practical assignment, we need 4096 words. Okay, and cell size means size of each word. We had 16 bits. Now, watch this carefully. That's all we have to do in RAM. And this is this. You see, it starts from 0 and the words go till 4095. So that makes it 4096. Now, if you saw that the length of each word of RAM, we can again go to RAM and see. See, this is the RAM we created. You see cell size. Let's make it. Cell size is 16. And watch it. This is 16. Accumulator register. Accumulator is also a register. This is 16-bit. Address register. Data register is 16-bit. Instruction register is 16-bit. This is not a coincidence. तुक्के से नहीं हो गया ये डिजाइन ही ऐसा होता है कंप्यूटर का कि जो मेमोरी वर्ड का साइज है सेम साइज एक्यूमुलेटर का बाय साइज आई मीन not the number of words in the memory, I mean the width of each word. How many bits can each word store? 16, 16, 16. This is a very important question for your theory exams also. Given memory size this, tell me the size of accumulator, data register, instruction register. Okay. Look at this now. What is this value? 4096. If you express it in terms of 2, 4096 is 2 raised to power 12, right? 2 raised to power 12. So the size of program counter and address register is 12. Why? Because the address register and program counter are going to store addresses of the memory. Okay, they are going to store addresses of the memory जो 0 से 4095 तक है. Whereas accumulator, data register and instruction register are going to store each word of the memory. That is why it is like this. Okay, I hope that makes sense. The next step, we are going to create instructions. Right? We are going to create instructions. And what are the instructions we are going to create? 1, 2, and add, load, store, clear accumulator, clear enable bit, complement accumulator, complement enable bit, and halt. These 8 instructions we are going to create. And the format of these 8 instructions is the following, right? This should be the format of these 8 instructions. 16-bit, 12 to 15-bit for opcode, and this is for address. And this opcode is going to be one of these, right? ये opcode होगा इसका. Okay. So in the next video, I'm not going to make the videos too long because it makes it heavy. So in the next video, we are going to see how to create these instruction formats. Okay.